Mathematics. Chapter name is Matrices. First, we will see what are the topics we will cover in this chapter. First of all, do you think matrix is a easy or a difficult chapter? What do you think? Let me know in the comment. First, we will read, then you will give your feedback that matrix is a easy or difficult chapter. First, we will see what are the topics we will cover in this chapter. The first topic we will cover is what is matrix. The second topic is general form of matrix. The third is the most important topic of this class, types of matrices. And the last topic is matrix operations. These are the four topics we will cover in this chapter. So among this is the introduction part, what is matrix, then the general form, then the types of matrices, then the matrix operations. From this matrix operations we will not cover the whole part, we will only study today addition part, some laws and some questions on addition and subtraction. The rest multiplication part we will study in the next class. So let's start from the first topic. So the first topic is what is matrix. First we have to know the meaning of this chapter, what is matrix. So the combination of rows and columns is called matrix. If we will construct rows and columns in a particular way, then it can form a matrix. So for example, we can say the rows are the horizontal lines and columns are the vertical lines. These two lines together form combination of both horizontal and vertical lines form a matrix. The form we can write in the form, this is the form of the matrix. These are the rows, these horizontal lines, these are the rows and these are the columns of the matrix. This is the basic introduction part of this chapter, which we have covered the first part, the matrix. This is simple, the combination of rows and columns. Then we will go to the second part. First we will see the order of matrix. Matrix is written in what order? For example, A equals to bracket some, let's say there are some elements in this matrix, and here the order which is written, it will be as the number of rows into number of columns, which is n cross m. N represents the number of rows and m represents the number of columns. Then the second topic, we will go to the second topic of this class, which is the general form of matrix. Let's say A is a matrix, name of the matrix is A. Then we can write the elements as, A11, A12, A13, A1n. Like that, A21, A22, A23, A2n. Like that, there will be many rows or many elements. Then like that, AM1, AM2, AM3, AMN. So here, this is the basic general form of matrix. Matrices are written in this form. So here the number of rows and number of columns are not defined. So the order of matrix we can write as m cross n. M is the number of it is n cross m. N is the number of rows and m is the number of columns. As the number of rows and number of columns are not defined, so we can write there this. And there is another way of writing matrix. The first way we have written as using a square bracket. The first way we have written as using a square bracket. The second way we can write using a parenthesis. It is same. We can use any form to write matrix, the general form of matrix. It will same as A11, A12, A1n, like that, AM1, AM2 up to AMN. It is the same. We can write in any form using square bracket or parenthesis, anything. Here also the order is same, n cross m, as the number of rows and number of columns are not defined. So we can write, for example, now we have studied the form of matrix. We are writing again the form of matrix, A11, A12 up to A1n up to AM1, AM2 up to AMN, m cross n, sorry, n cross m. So here, what is A? A is the name of the matrix. The name of the matrix are written as A. We can write if we are naming a matrix, then we can give the names from capital A to capital Z. Capital letters are used to naming the matrix. If the matrix is A, then the elements will be written in small a. So, like that, for elements of the matrix, we can write small a to small z. These are the used for naming. Like that, for this matrix, for naming purpose, we are writing A m cross n. This is used for naming. And the elements are written in small a, so we will write A I J. This represents elements. This represents elements of a matrix. As here M cross N also represents the rows and columns, here I and J also represents rows and columns. Let's give an example of a matrix. Let's take let's write that let's take A is a matrix 1 2 3 4 1 2 3 4. So how we can write the order of the matrix? Here we will count first the number of rows. The number of rows are 1, this is the first row and this is the second row. So we will write it 2 cross number of columns 1 2 columns. So the order of matrix is 2 cross 2. So we will say what are the elements in this matrix. So A11 is 1, A12 is 2, A21 is 3 and A22 is 4. These are the elements of the matrix. And the order of this matrix is 2 cross 2. Like that we can extend up to anything. Let's give another example. For example, A is a matrix. Inside we can write 1 2. So here we will see that there are only 2 elements. It can also, 2 elements can also form a matrix. So how we can write this? The order of the matrix is, there are 2 rows and there is only 1 column. So 2 into 1. The order of the matrix is 2 cross 1, and A11 is, this is A11 and this is A22. Sorry, A21. This is the form of matrix. We can write also make matrix using one element also. Now we will solve a question. We will take an example. Question is given that if A equals to 2i minus j. Question is given that A is equal to 2i minus j, means all elements, the formula for writing all elements of the matrix A is 2i minus j. Then the first bit question we have to find A23. So inside the matrix we have to find the element named A23. A23 means the row is 2 and the column is 3. So here I represents row and J represents 3. So we will put the value 2 and 3 to I and J respectively. So how we can find 2I minus J, 2 into 2 minus 3, 4 minus 3, which is 1. The value of A23 is 1. Then we will move to the second bit of this question. The second bit is given that to form a matrix of 3 cross 2. Let's see. 3 cross 2 matrix means the number of rows are 3 and the number of columns are 2. We have to form the second bit is to form 2 cross 3 matrix. Sorry, it is 3 cross 2 matrix. So first we will write the order, we will write the form of the matrix, then we will put the value to it. For 2 cross 3 we have to make 3 rows. For 3 cross 2 we have to make 3 rows and 2 columns. So A11, A12, A21, A22, A31, A32. So the order of matrix is 3 cross 2. These are the elements A21, A22, A11, A12, A21, A22, A31 and A32. So here we can see there are 3 rows and 2 columns. So we have to form this matrix, means we have to write all the values of the elements in the matrix A. So we have to put the formula given in the question 2I minus J. For the first question the value of row is 1 and the value of J column is 1. So we will put the value 2 into 1, 2 minus 1, the value is 1. And A12 means 2 into 1, 2 minus 2, 4. So 2 minus 2, 0. In the A21, 2 into 2, 4 minus 1, 3. And the A22, 4 minus 2, 2. And for the last row A31 is 6 minus 1, which is 5. And A32, which is 6 minus 2, which is 4. This is the form of the matrix. This is the final result of this question. This is the answer. Okay. So next we'll see there is a very important rule for the matrix. For say there is a matrix given as Z. The name of the matrix is given Z, and in the matrix Z the number of rows equals to X. Let's see, we don't know the number of rows, so we'll take the number of rows as X and the number of columns as Y. So here number of rows and number of columns are not defined, so we can take X and Y. So this rule says that if a matrix has X number of rows and Y number of columns, then the total number of elements in this matrix is X into Y. So total number of the order is X cross Y, and the total number of elements in this matrix is X into Y. Total elements is X cross Y. Let's take an example for it. We have taken the example as matrix named Z. So we will take Z equals to 1, 6, 7, 3. The order is there are 2 rows, so 2 cross two columns 2 cross 2. So let's take this is x and this is y. X into y, 2 cross 2 into 2 is 4, and we can see there are 4 number of elements in this matrix, which is 1, 6, 7 and 3, total 4 number of elements in this matrix. So this law satisfies. Next, it is the most important part of our class, which is types of matrix. In this class we will know various types of matrix. There are minimum 7 to 9 types of matrices we will study. This is the main part of our class. So let's start with the types of matrix. The first part is row matrix. The first type is row matrix. Row matrix means the matrix which consists only rows. There will be only one column, and there will be infinite number. We can write infinite number of rows, but the number of columns will be one. We can write n number of rows, but the column will only be one. Let's take an example. Let's say A is a matrix. We can write A1, A11, A21, A31 up to AN1. This is the order of the matrix n cross 1. Here number of rows is not defined. We can write n number of rows. In row matrix, it means it contains only rows. Number of column will only be one, and there can be any n number of rows. It can be infinite also. It is just opposite of the column matrix, which we will study next. Next, the type of the matrix is column matrix. Next is column matrix. As I said, it is just the opposite of the row matrix. It consists of only columns, and the number of rows is only one. Number of rows is only one, and there can be n number of columns. We can extend up to anything. It can be an infinite also. So let's write the general formula of it. A11, A12, A13, A1n. So the number of columns can be anything. It can be infinite, but the number of rows remain only one. So the order is 1 cross n. The order of row matrix was n cross 1, and the order of column matrix is 1 cross n. It is just opposite of each other. We can write n number of columns, but the number of rows should be 1. The next topic. Next is null matrix. Next is null matrix. Null matrix, or we can say it as empty matrix. We have already studied the chapter set. In this chapter set, we have also came to know about null set. What null set represents? Null set represents about the empty set, or the set that contains no elements. So in case of matrices also same, the matrix which contains no elements. It is 0 cross 0. We can write nothing. We can write because it is not inside that there will be no elements. It is same as set. If null set, we can say there are no elements in that set. So in null matrix or empty matrix, or we can say zero matrix, the number of elements are 0. There is nothing. Then the next type of matrix we will study is square matrix. It is the fourth type of matrix we will study, square matrix. Square matrix means equal number of rows and equal number of columns. For example, if we take a matrix, the number of rows means n, the order of a general form of matrix, the order is n cross m, then n should be equal to the m. Let's write the general form. The order is n cross m. So this is the general form of the matrix, and if we see about square matrix, then the number of rows and number of columns should be equal. Means the order n cross m, the n should be equal to m. Let's take an example of 2 cross 2 matrix. Let's take an example of 2 cross 2 matrix 1 2 5 6. Here the number of rows are 2 and the number of columns are also 2. So the order is 2 cross 2, means number of rows and number of columns are equal. So we can say this matrix is a square matrix. Then another type we can say 3 cross 3 matrix. This we can say as 3 cross 3 matrix. Here also number of columns and number of rows are same, so here it is also called square matrix in 3 cross 3 order. We can write in 1 cross or n cross n. The fact is the number of rows and number of columns should be equal. Let's move to the next type of matrix. The next type of matrix is one term matrix. One term, or we can say as single matrix. Single means what? One term matrix also represents that the number of elements in the matrix is only one. Let's write the general formula. A equals to Aij. The number of elements in this matrix is only one, so the order will 1 cross 1, as here the number of rows and number of columns is only 1. So in simple words, we can say one term matrix or single matrix is the number of elements will be 1. And the order is only 1 cross 1. So we can say that one term matrix is also called a square matrix, but all square matrices are not one term matrices. This is the fact. Then next move to the another type of matrix. Next is the identity matrix, very important topic. This is the 6th type of matrix, which is identity matrix. Identity matrix represents that the main diagonal of the matrix will be 1. All the elements in the main diagonal of the matrix will be 1. Let's give an example. Let's say set named A. Elements are 1 0 0. The order is 2 cross 2. Can we say this identity matrix? Yes, we can say this as identity matrix as the main diagonal. Main diagonal means this is the main diagonal. This main diagonal, all the elements in the main diagonal will be 1. That is called identity matrix. And let's give an example of 3 cross 3 matrix. Matrix named A. matrix named A. So this can also be called as identity matrix. The order is 3 cross 3. This can also be called as identity matrix, as the main diagram, these three elements are the elements of the main diagram are 1. And another way of writing the identity matrix is this, the triangular form. These zeros will form a triangular form in 3 cross 3 matrix. Okay, and the identity matrix are denoted by capital letter I. This is the main point. The identity matrix are represented as capital letter I. The next type of matrix will go. Next type is symmetric and skew symmetric. These are the two most important topics or types of matrix we can say in class 12 matrix chapter. These are most important, and if you listen properly, if you will try to understand, then you can understand it easily. Before going to symmetric and skew symmetric, we have to first understand what is transpose of matrix. So let's go to transpose of matrix. First we'll study transposer matrix is not a type of matrix. We are learning transposer matrix to understand skew matrix and skew symmetric matrix. Transposer matrix helps us to understand symmetric and skew symmetric matrix. So transposer matrix is simple as we can say then elements in rows become the elements in columns, and the elements in columns become the elements in rows. Just they are interchanged. Let's give an example. A11, A12, A13, A21, A22, A23, A31, A32, A33. The order of matrices 3 cross 3. Then what will transpose the matrix? First of all, transpose of matrix is represented as capital A, and in above we can write a small t, capital letter T but small. Then how will write the transpose of A? This row, the elements in row will become the elements of column, and these elements of column become the elements of rows. First we'll write A11, A12, A13. Then the second row will become second column A21, A22, A23. Then the third row will become the third column A31, A32, A33. This is the general form of a transposer matrix, where the number of rows become number of columns and the number of columns become number of rows. Then we will see the next. Now we have studied the transposer matrix. Next we will go to the symmetric matrix. Symmetric then skew symmetric. These are the last two types of matrix, and this topic will be covered. We will see the seventh type of matrix is symmetric. Symmetric matrix. So let's say that there is a matrix A. Then we can say the matrix A is symmetric by as the elements of matrix A is equal to the elements of matrix A transpose of A. Means the elements of matrix A is equal to the elements of transpose of A. You can simply write that A equals to A transpose. Let's take an example and cover it. Let's say A is matrix 1, 1, 1, 1. These are the elements. It's a 2 cross 2 matrix, and transpose of A will be also 1, 1, 1, 1. So here the A is equals to A transpose of A. So here we can say the matrix A. The matrix A is a symmetric matrix. as all the elements of A and transpose of A are equal. So another thing we can say that matrix A and its transpose, the order of both the matrices are equal, means order of matrix A and order of transpose of A are equal. If someone can understand the transpose of matrix, then he or she can easily understand the symmetric and skew symmetric matrix. Let's move to the next part. Next is skew symmetric matrix. Skew symmetric is we have studied now symmetric matrix, which is A equals to minus of A transpose, and skew symmetric symmetric is A equals to minus of A equals to transpose of A, and skew symmetric is A equals to minus of A transpose. For example, symmetric was A equals to transpose of A, skew symmetric is A equals to minus of transpose A. The means minus of transpose A means if we'll add multiply minus to all the elements of the transpose of A, it must be equal to the matrix A. Then we can say the matrix A is a skew symmetric matrix. Then we'll move to the next part. And this was the main part of our class, which is types of matrix, which we have covered. The next and last topic of our class is operations of matrices. There are basically three operations of matrices. There are basically three operations of matrices. First is addition, then subtraction, then multiplication. Multiplication and addition have some laws which we have to prove it. Today in this class we will study first addition and its law and some questions regarding addition and subtraction. For the part of multiplication operations we will study in the next class. So in this class we will cover only addition and subtractions and some laws of additions. Simply addition means adding both matrices or adding the elements of the matrices. Let's give the general formula. Let's say A is a matrix A11, A12, A21, A22 of order 2 cross 2, and B is a matrix of elements B11, B12, B21, B22. The matrix A contains the elements A11, A12, A21, A22 and same as matrix B. So how we can write? The addition means simply A plus B. A plus B means we'll add first element of matrix A to the first element of matrix B. So A11 plus B11. The first element of A plus B is A11 plus B11. Second element is A12 plus B12. Third element A21 plus B21. Fourth element is A31 A22 plus B22. The order is same as 2 cross 2 matrix. There is a fact that the addition of matrix is only possible when the order of both the matrices are equal. Like say here the order is 2 cross 2 and here the order is 2 cross 2, then only the addition is possible. If the order will be different, like one matrix will be have 2 cross 2 order and another matrix will have 3 cross 3 order, then the addition is not possible. For addition, the order must be equal. We have given the general formula. Let's give an example. Equals to, let's say 1, 2, 3, 4, 2 cross 2 matrix. B is equal to 7, 8, 9, 10. 2 cross 2 matrix. So you can write A plus B as first 1 plus 7 8, 2 plus 8 10, 7 plus 3 10, and 4 plus 10 14. The order of both the matrices is same, and the resulting matrix, the order of resulting matrix is also same. So here are the notes of the class. If anyone wants to write, they can write. The next very important part of the addition is the laws. There are two laws we will cover in this class. There are only basically two laws of addition. One is commutative law and one is associative law. First we will study commutative law. First, commutative law states that if a matrix name A and another matrix name B, then A plus B equals to B plus A. This is the most simple law of matrix. We can say A plus B is equals to B plus A. We'll give an example and understand this question. Let's take one matrix A equals to 1 2 2 1, and another matrix B equals to 3 4 7 9. These are the two matrices. First, LHS part is the LHS part of the matrix is A plus B. So A plus B equals to 1 plus 3, first element of matrix A to the first element of matrix B. So 1 plus 3 4, 2 plus 4 6, 2 plus 7 9, and 1 plus 9 10. This is the LHS part. This is the LHS part of the law, which is A plus B. Then we will solve the RHS part, which is B plus A. B plus A means 3 plus 1, which is 4, 4 plus 2 6, 7 plus 2 9, 9 plus 1 10. So you can match both the LHS and RHS part, which are equal, and the elements inside it are also equal. So this law satisfies, and this commutative law only satisfies in case of addition, not in subtraction or multiplication. The next very important law is associative law. Associative law. This law states that A plus B plus C, let's say and matrix A plus in bracket B plus C equals to in bracket A plus B in bracket plus C. This law states that A plus inside bracket B plus C equals to A plus B plus C. We will give an example and solve this law. Let's take an matrix A equals to 1 0 0 1, B equals to 2 7 3 1, and matrix C equals to 1 9 3 4, and all the order of matrix should be same, which is 2 cross 2. So first we'll do the LHS part. LHS part is A plus in bracket B plus C. So first we'll do B plus C. B plus C is 2 plus 1 3, 7 plus 3 10, 1 plus 9 10, and 3 plus 4 7. So B plus C is 3 10 10 and 7. Next we will add A to B plus C. If you add A to B plus C, then 3 plus 1 plus 3 4, 0 plus 10 10, 0 plus 10 10, and 1 plus 7 8. This is the resulting answer of LHS, which is 4 10 8, 4 10 10 and 8. Then we will solve the RHS part. Next we will solve the RHS part. RHS part says that A plus B in bracket plus C is equal to same. So first we will solve the A plus B part. A plus B is 2 plus 1, which is 3, 0 plus 7 is 7, 0 plus 1 1, 1 plus 3 4. The order is 2 cross 2, and then the next part will add C to A plus B. So we'll put A plus B inside bracket plus C. 3 plus 1 4, 7 plus 3 10, 1 plus 9 10, and 4 plus 4 8. As you can match LHS to RHS, the resulting answer was same, 4 10 10 8. So here we saw the associative law also satisfies in case of addition, and in case of subtraction and multiplication, the associative law may satisfy or may not satisfy. Next, today's class all topics have been covered. Now we'll do some questions. Okay, here first question, given that matrix A, elements of matrix A are 1 9 6 7 8 4 2 cross 3, and element of matrix B are 7 3 6 and 5 3 6. The order of matrix is also 2 cross 3. So the first bit is given to do that A plus B. It's a simple one. A plus B is 1 plus 7 8, 9 plus 3 12, 6 plus 6 12, 7 plus 5 12, 8 plus 3 11, 4 plus 6 10. The order of the resulting matrix will also be same, 2 cross 3. This is the answer of A plus B. Then we will move to second bit, which is given to find A minus B. A minus B is 1 minus 7 is minus 6, 9 minus 3 is 6, 6 minus 6 is 0, 7 minus 5 is 2, 8 minus 3 is 5, and 4 minus 6 is minus 2. This is the resulting matrix of A minus B, and the order also remains same as 2 cross 3. This is a very simple question. Next, move to a bit complicated. Next question is very interesting question. Given matrix A is a 3 cross 3 matrix given 3 7 2 3 9 5 4 6 1. This is the matrix of matrix A. And next, the matrix B is given as 3 7 4 9 6 5 2 9 1. This order is also 2 cross 3. So here the first bit is given to find 4a plus 3b. You might think this is a bit confusing one, but 4a plus 3b is just multiplying 4 to all elements of matrix A. So first we will find 4a. I can erase this one, but because the question is given in the screen. First I will find 4a. 4a is 4 into 3, which is 12. 4 7s are 28. 4 2s are 8. Then 12, 36. Then next one is 20. Then 16. Then 24. Then 4. And this is 4a, means 4 multiplied to all the elements of matrix A. Then 3b. 3b is 3 multiplied to all the elements of matrix B. This first element is 9. Then next is 27. Then 18. Then 21. 15. Then 6. 12. 27, 3. The order is 2 cross 3, and here the order is also 2 cross 3. So 3b, we have found 3b. The next task is to find 2a plus 4a plus 3b. 4a plus 3b. For 12 plus 9, which is 21. 28 plus 27 is 55. 8 plus 18 is 26. 21 plus 12 is 33. 30 plus 15, 45. 36 plus 15, 51. 20 plus 6 is 26. 16 plus 12 is 28. And 24 plus 27 is 51, and 4 plus 3 is 7. This is the resulting matrix, which is 4a plus 3b. The next bit is to find 4a minus 2b, which is your task. You will find out the answer and comment below. Next question, we'll move to the next question. Next question is given to construct a matrix of 2 cross 2 matrix. Order is 2 cross 2. So let's write the order. This is a 2 cross 2 matrix. So the formula of the elements are also given in the question, which is Aij. I represents row and J represents the column, as I have said before. And the formula of Aij is I minus 2j whole square divided by 2. So we will find all the elements. A11 equals to 1 minus A11 is 1 minus 2 whole square by 2, which is equals to minus 1 whole square is 1 by 2. Next is A12 equals to 1 minus 4 whole square by 2. Minus 3 whole square is 9 by 2. Then is A21, which is 2 minus 2 whole square by 2 equals to 0 square by 2 equals to 0. Next is A22 equals to 2 minus 4 by 2 square, which is minus 2 whole square by 2, which is 4 by 2, resulting answer will be 2. So the elements are 1 by 2, 9 by 2, 0 and 2. Let's construct the matrix. If there are any doubts in solving these questions, then let me know in the comments. Let's construct the matrix. A equals to 1 by 2, 9 by 2, 0 and 2. This is the resulting matrix 2 cross 2. Next, I have some questions for you all. You will solve it and let me know in the comment. And after this question, we will wind our class. It is given that x minus y, 2x minus y, z, w equals to 1, 4, 0, 5 to find x plus y. So this is the first question is given task to you. You will write this question, solve it and answer, comment the answer below. Basically this question given is that this matrix is equal to this matrix. You can name a matrix as A and this matrix as B. And this matrix is equal to this matrix, so x minus y is 1 and 2x minus y is 0. So you can solve it by taking two equations, and here you have to find the main answer. You have to find is x plus y. You find the value of x and y, then add it. There is no work of z and w. This is just given to confuse you. The next question and the final question is, next question given a plus 4, 8, 3b and minus 6 equals to 2a plus 2, 8, b plus 2, a minus 8b. This question is also same as here. This question you have to find a minus 2b. In this question it is same as the previous question. It is also given to find the value of a plus a minus 2b. It is more easier as compared to the last question, because the last question you have to make two equations and solve it, but in this question you can directly solve it, because this side a plus 4 is equal to 2a minus 2, 2a plus 2. So it will be more easier to solve. So these are the two questions for you, and with these questions we will end our class. And thank you for today. In today's class we have read all the operations, all the types of matrices, and the operations part we have read only additions and subtractions. We have solved many questions, and some questions are given as tasks also. In the next class we will study about multiplications and its laws. Thank you.